Friends, today I'm going to design a 12-volt stabilized power supply. Let's start by designing the circuit diagram. So we're going to convert the main AC into DC. So the first component, we need a step-down transformer. Remember that what we want to achieve at the output is 12-volt DC. So we will be using the main AC 240 volt as the source. We connect it to the step-down transformer. The step-down transformer will step down the voltage to a manageable level of voltage close to what we want to achieve at the output. After stepping down the voltage using a step-down transformer, we need to convert this voltage coming from the transformer into DC. Remember that the AC signal looks like this, then the DC signal looks like this. So this dot here indicates that it doesn't change any direction. So this dot indicates here that this type of current does not change any direction. And then we have the alternating current. In short, we call it AC. This changes direction. At a time is positive and at a time is negative. So we need to remember we want to take this form of signal to this form. So for us to be able to rectify this form to this, we need semiconductor diodes to convert AC into DC, or to rectify the AC into DC. So in this project, we are going to use a bridge rectifier method using 4 diodes. So we need to rectify both halves, the positive and the negative. So this is how it works. Let's take the positive side. When it is positive, the current will, let's assume that this side is positive, the current will come and pass through you'll find this diode forward bias. Then it'll pass through this diode, it will be rectified and continue through the system, and it will return from here. So this side is a higher potential, so the current will not go there, that side, so it will go that way and return back to the system. And when this becomes negative and this becomes positive, the current will flow this way and flow through this second diode, and it will go through the system. So when it returns, it will return to this point back to the system. So it will continue like that. Remember that when designing this, the positive is maintained on one side and the negative is maintained on the other side. So this rectified DC still contain AC components. So we need to come up with a way to remove this AC component from the rectified DC. So guys, this is how a pi filter look like. What's a pi filter? A pi filter is a type of filter which is made up of 3 components: a capacitor, an inductor, and a capacitor. So it means it has 2 capacitors and 1 inductor. How does this work and filter the AC? Filter the DC, the rectified DC, and remove the AC components from the rectified DC. When the rectified DC will come here is already DC. So this DC which is coming still contain some AC component inside. Okay. So this DC will come and reach this point. So the capacitor offer high reactance to AC but low reactance to DC component. So the capacitor at this point, the capacitor, the AC, that DC will come, the capacitor will only allow the DC signal to pass, but not the AC. So it will short all the AC component from this first capacitor. Okay, so this first capacitor will short the AC component and filter it and remove it from the rectified DC. Since things made by human beings are never perfect, some of AC components will still exist through the rectified DC, and it will escape from this capacitor. When after escaping, it will continue through the system. So it will also find the inductor. So the inductor is at this point. Inductor offer high reactance to AC component and low reactance to DC components. So meaning that most of the AC components which will escape from the first capacitor will be blocked by this inductor. So the inductor will block all other remaining components which were escaped from the first capacitor. Since the same scenario, we say that things made by human beings are never perfect, some other AC component will still escape from the inductor. So all the remaining one now will be shorted by this capacitor. So if there is any AC component from the rectified DC which is coming this way, if any AC component escapes from the inductor, this last capacitor will now short it down. So that is how a pi filter works. So this type of filter is one of the best filter ever, because this is more efficient compared to LC filter and capacitor filter, what we discussed last time. So the output of this pi filter is quite smooth compared to LC and capacitor filter. So the output of at this point here, the output signal will look somehow like this. Then now, after filtering, now we need to achieve 12 volt at the output. So we'll have to measure the voltage after filtering. So now, this is where it's going to make the difference between a linear power supply and a stabilized power supply. For a stabilized power supply, what we are going to do, we are going to connect a resistor here, and we are going to connect a Zener diode here. So we're going to connect a Zener diode at this point, okay? So we're going to connect a resistor and a Zener diode. So this resistor is a current limit resistor for the Zener diode, okay? So this is Zener diode. So this is the current limit resistor. This protects the Zener diode from not burning from the excess current, okay? So this Zener diode is going to stabilize the voltage at this point. So we're going to connect a comparator. Let's connect a comparator and explain how it works. Let's connect a comparator. So we have connected a comparator, okay? This is how a comparator looks like. This is its output. Then we'll have to connect a voltage regulator at this point, okay? Then we'll have to connect a transistor at this point. Transistor where the base is connected to at this point. And the emitter, okay? The emitter is connected to pin 3 of this. The emitter and the base, and the collector is connected to the output of this op-amp, okay? This op-amp, and it's connected to one of the pins of this, okay? So this is the emitter, collector, and the base of this transistor. Then we have the output. Now the output here, let's connect an LED here, an LED, and see what will happen. Then we take this one. So there is these two pins. So one of the pin is connected here between the resistor and the Zener diode, and one of these is connected at this point. So how does this work, sir? This is how a stabilized power supply work. First of all, the 244 AC is fed to the step-down transformer. This step-down transformer steps down the 240 volt into 12 volt AC. So this AC, 12 volt AC, is fed to a bridge rectifier. The function of this bridge rectifier is to rectify the main AC into DC, as we explained earlier. So after getting DC here, this DC still contains some AC components. So we need to filter this DC and remove the AC component from the rectified DC. So for us to be able to do that, we are using a pi filter made up of 2 capacitors and an inductor, as we explained how it works earlier. Then after the filter, we'll get a smoothened DC, okay, something smoothened, whereby there is no AC component in that rectified DC or filtered DC. Now at this point here, this is where it makes difference from other types of power supply we designed before. We connect a Zener diode at this point here. This is a current limiting resistor. So this current limiting resistor is here to protect to control the current which is going to the Zener diode. So this Zener diode will have to regulate it will regulate this voltage at a certain level. Then this regulated voltage is fed to one of the pin of the comparator or the op-amp. Op-amp when used as a comparator. Then this is connected to the positive and negative to power this device. Okay. Now another pin is connected to the output, as you can see at the output here. Then the output of this comparator is connected to the collector of this transistor. How does this one work? This one takes the responsibility of anything which will happen at the output. Which one? The fluctuation. If there is any fluctuation in voltage level at the output, this will take care of it and make sure that it stabilizes the output voltage. Then this one, now after the comparator is connected to the voltage regulator IC 7812, this now will provide us a 12 volt at the output. So at this level here between, we'll get a 12 volt at the output. Now after that, you can see this output of this comparator is connected to the collector and the base is connected here and the emitter is connected also here. The function of this transistor here is to control the amount of current which is going to the load. So this transistor here will make sure that the load receives the required current, not the excess current. So this one is just a current limiting resistor for the LED which I've drawn here. So that is how a stabilized power supply works. Now we need to go physically and design this power supply and test it out to see how it works.